Good evening to all. Today we are going to discuss a new topic, that is research and statistics measures of variability unit 3. In that measures of variability, we are going to discuss range, percentiles, average deviation, quartile deviation and standard deviation. So before going to that, we need to know that what is measures of variability or measures of dispersion. Here, the measures of variability describes how spread out in a data set, means how the data is spreaded out and how much values are differ from each other, and from the center we are going to check its spread out, data spread out. So next we are going to move towards range. So range is here the difference between highest and the lowest value, like highest observation the value and the lowest one. After different or subtraction, we'll get the range, average range of the value. Then we'll move on towards the average deviation or a mean deviation. So here the average amount of scattered information in a distributive form, either mean or median, ignoring the signs of deviation. So here we have a formula, that is mean deviation is equal to summation of x minus x bar, and which is covered by a modulation and divided by n. So, quartile deviation is the middlemost value in a dataset which is arranged in ascending or descending order. If the series are divided in 4 equal parts, then it is used to call it as quartile deviation. And the quartile deviation is denoted as Q1, Q2 and Q3. So here Q1 is the lowest quartile in the whole dataset. Q1 indicates that the 25% of data, and the fourth in the whole dataset, fourth part means the dataset is divided into 4 part, and that is considered to be Q1 as the lower one. Q2 is the middlemost and the median, and used to call it as 50%. And Q3 is upper quartile, and which is of 75% or more than 75%. So we have some formulas for calculating Q1. So Q1 n plus 1 divided by fourth observation after arranging the data. So whatever data we'll get, we have to arrange that in ascending or descending order. And Q1 is the fourth, n plus 1 divided by fourth observation of the arranged data. And Q3 is 3 multiplied by n plus 1 divided by fourth observation after arranging the data. So here quartile deviation is equal to Q3 minus Q1 divided by 2. And one more component, that's interquartile deviation, which is nothing but Q3 minus Q1. Next we'll move on towards standard deviation. The standard deviation tells how much data or how much number of sets of data are spread out. It measures how much individual data points vary from average of a data set. So the low standard deviation means data points are clustered or cloudly around the mean. If the high data set indicates the points are more spread out. So here sigma, this sign sigma indicates that the standard deviation for population, and yes, the sign indicates that standard deviation for the samples. So we have again a formula for standard deviation. So when the data is ungrouped, standard deviation is equal to whole square root, and under which summation of x minus x bar whole square divided by n. And for standard deviation for grouped discrete and continuous data, we have a formula, that is standard deviation of square root under sigma summation of f x minus x bar whole square divided by capital N. Again, one more component we are going to discuss, that is coefficient of variance, that is CV, is a statistical measures of relative dispersion of data. It is particularly useful when want to compare the variability of data sets that have different units and different mean. So the CV, coefficient variance, is equal to standard deviation divided by mean into 100. So we'll take an example and we'll discuss with this problem. The problem is calculating the quartile deviation, mean deviation, standard deviation and CV for the given data. They have given a data in randomly organized. We have to organize this data in ascending or descending order first, then we'll do the calculations. So we'll take a variable x. We'll arrange the data. So 5, 6, 10, 12, 13, 14, 15, 17, 18 and 20. So totally we have n is 20 characteristics, like 1, 2, 3, 4. After counting this, we'll get, so summation of x bar, we have summation of x, we after adding these all variables, we'll get a value that is 130. So we'll do here, that is we'll take x minus x bar as one more component, and finding x bar is the next task to us. So finding x bar, which is nothing but summation of x divided by n. So summation of x, we have 130 divided by n is nothing but 10. So we'll get of 13. So what we have to do next is 5 minus 13. So we'll get an answer to be negative. We'll get the answer to be negative, but after removing this modulation, whatever answer is there, if plus is there, we'll get plus. If minus, then also it is plus, because modulation means nothing but taking the value as to be a positive one. So after subtracting this, we'll get 8 followed by like that only 7 and 3, 1, 13 minus 13 is 0, 1 again, 2, 4 and 5, and this is 7. So, and this summation of x minus x bar is equal to, we'll get, after adding all these variables, we'll get a value that is 38. And again the next very moment is calculating x minus x bar's whole square. To calculate standard deviation, we have to do this, and this will get by doing squaring the values. We'll get as 9, 1, 0, 1, 4, 16, 25 and 49 1. So after adding all these values, we'll get sigma x minus x bar whole square is nothing but our value. It's 218. So next we have to calculate that range highest minus lowest, which is nothing but highest is 18 and the lowest one is 5. Sorry, highest one is 20 here. Highest one is 20. So 20 minus 5, which is nothing but 15. This is our range. So next we have to calculate mean deviation. Mean deviation. So mean deviation, we have a formula that is summation. So summation of x minus x bar divided by n. So we have got this as 38 divided by 10. It's about 3.8. So next we will do a calculation of quartile deviation. So before doing the quartile deviation, we need to know the formula Q3 minus Q1 divided by 2. But we need to know that Q3 and Q1 value. So what we'll do first, we'll need to know that Q1 value. Q1 is nothing but n into n plus 1 divided by 4th observation. So we have n as 10. 10 plus 1 divided by 4, which is nothing but 11 divided by 4. We'll get this value around 2.75. So we'll consider it as 3. So third value in the observation data set. So this is 1, 2, 3. So this 10 is going to be our Q1. 10 is 10th third observation, 10 is our Q1. Then we'll move on towards the Q3 is equal to same formula but multiplication by 3, the observation. So we have 3 into, directly also we can do, if we want we can multiply by this, and through also we can go with this. So we'll get a value of around, which is nothing but 8.25. We'll consider to be a 8th observation. So 8th observation, what we have is going to be 1, 2, 3, 4, 5, 6, 7, 8. So 17 is our Q3. So we have two values, that is Q1 and Q3. Then we can calculate QD. So QD, which is nothing but Q3 minus Q1 divided by n, which is nothing but, sorry, it's divided by 2. So we have to be 17 minus 10 divided by 2, which is nothing but 17 minus 10, 7 divided by 2. Again, it's about 3.5. So quartile deviation is 3.5. So next we'll move on towards standard deviation. We have a formula of square root summation of x minus x bar whole square divided by n. So we have already calculated this summation of x minus x bar whole square value. So directly we'll keep this as it is. It's about 218 divided by 10. So we'll get the value around it's about 21.8, which is nothing but after calculation we'll get 4.66. So followed by, we need to calculate CV, which is nothing but coefficient of variance. We have a formula for that, standard deviation divided by mean into 100. So standard deviation we have 4.66, just now only we have calculated. Then mean we have 13, because we already calculated this x bar value is our mean. So we have 13, and we'll multiply this by 100. We'll get a CV around 35.84% of CV. So here our calculation will end up for the one problem.